question of this term. This session is all about developing your programming skills with the Turing Tumbles. My name's Suzanne Cray and I'm the host for this session. We've got a busy session this time, so there's not going to be a lot of time for questions today, but if you have any, please pop them in the question window or ask on the website afterwards and we'll pick them up. All attendees today are in listen-only mode, and today I'm very pleased to say we are joined by our very own Simon Howe, who will be doing some demonstrations for us, and Nikki Turing. Nikki spent her professional life working for the NHS as a gastroenterologist. During that time, she developed an interest in using IT to improve patient care. Since she retired, she's been volunteering for the Turing Trust and is passionate about ensuring that all students have an access to a technology-enabled education. Her roles at the Turing Trust include finance, managing the website, and developing the e-learning provided on the computers they send out to Africa. So without further ado, I'll hand over to Nikki and Simon to continue today.
Thank you very much. What today is about is a way of actually trying to engage all pupils with understanding how a computer works. Some people have a fantastic imagination and can imagine what it is that's happening inside that black box, but for other people, actually being able to get their hands on bits and manipulate them themselves can make a real difference to their understanding. You can see from my first slide that actually if you let the adults get it first, then the kids don't often get much of a look in, and that applies in the UK and in Africa, it seems. So today what we want to do is to introduce you to how to use Turing Tumbles within the classroom so that your students can learn coding principles and how to actually challenge their thinking, so they have to work out these logic problems and how to make this work for themselves. And then Simon's going to talk a bit more about some of the activities that you can do with them to get them to really extend beyond what the basic book teaches them how to do. So what is it? Well, it's basically a marble-powered computer. So you can see in the box here, you have a board, you have a stand for it, you have a puzzle book, and I'll talk a bit more about that later, and you have various sort of bits that you end up putting on the board. And the thing about the puzzle book is that it builds on concepts as you go through, but it does it in a very fun way. It's a graphic art illustration of somebody trying to solve problems in space. Now, you may say, well, how on earth can this possibly be Turing Complete? Well, I will show you in a minute with the different pieces, but it does mean that if you had a big enough board, if you had enough pieces, then theoretically you could do anything a computer could do, but it would have to be an enormous board. The other thing I thought I would just mention as a sort of sideshow here is, well, is this very new? Well, it is, but actually this is going back to Alan Turing's days at King's College, Cambridge. And he and a friend were trying to solve the Riemann zeta function. And they were trying to do it using mechanical gears. And apparently those gears had the same number of teeth as prime numbers. Unfortunately, you then had World War II, so this didn't get much further than a whole set of gears strewn across his room at King's. But I think it shows that Alan also liked this sort of visual aspect of trying to see and understand how things were working. So I've talked about the board here, and a couple of things just to point out is you've got two levers at the bottom, and they're connected to this at the back via a very simple sort of pulley system. And so if you press this lever down, then a ball will be released from this ramp here. You have a whole series of different type of bits. So you've got ramps, which they liken to just straightforward wires in a computer. You've got crossovers, very obvious crossover wires. You've got bits that act a bit like transistors. Interceptors, well, how do you stop your program? But the really fun bit gets when they start using the gears and gear bits, because that means that information can flow in all directions through the board. And so you can start getting logic and loops in there to really reinforce the whole programming concepts. And this is the puzzle book I mentioned here. So just so you can see for yourselves the sort of things and the way it's presented in the puzzle books. And the idea is that you want to engage the kids in a way that is meaningful for them. So you have a story going alongside the concepts. Each puzzle will come with a challenge, and they get an objective. They're told what they have to achieve, and then on the side here, you get the bits that they've got available to solve that problem with. And the challenge is for them to work out where they have to put those bits on the board to actually get the balls to do what it says in the tin. So there's a lot of resources there to back up how you use your Turing Tumbles. So it's not like you get to get your first tumble and then you have to try and work out how you're going to introduce it in the classroom. There are a couple of videos that explain how to use it in the classroom, but also how Turing Tumble is actually equivalent to the sort of PC that we use these days. There are guides, and very helpfully, the educator guide and the practice guides give you solutions to that. So you're never going to be left on your own. But they will also give you what it is that the players of this particular puzzle are supposed to be learning for this. So you've got your learning objectives and things already set out for you. Simon is going to show you the simulator. So again, even if you haven't got your own tumble, you can go online and you can practice online. Obviously, part of the aim of this is to get kids away from the screen when they're doing this. So I'm not suggesting necessarily you'd want to do that, but it's a very useful way of demonstrating stuff, perhaps at the beginning of class or something like that, or indeed just having fun yourself. They have an educational blog, so from time to time they will put in lesson plans for specific things and keep adding to that community knowledge. And then there's the Turing Tumble community, and on there a whole load of people are posting different solutions to same problems, posing new problems, so things like pi, random number generation, and things like that. So people are continuing to learn and to develop this. But rather than have me go on about it anymore, because you can probably tell I'm a bit of an enthusiast, I'll hand you over to Simon so he can actually show you how it works in practice.
Thanks, Nikki. Did you all, just before we show it on the board, did you all just tell everyone a bit about the Turing Trust and maybe how their schools could support the Turing Trust?
Oh, absolutely. Thank you. Yes, very nice to be invited to do that. So the Turing Trust is a charity that was set up by my younger son back in 2009 when he did a gap year. Started in a very small way, but has actually grown to a really quite big organisation now, such that we had a ministerial visit this morning to actually see what we're doing, and hopefully that'll help in terms of getting grants, but also in terms of getting more donations. And what we're doing at the moment, our main project, is trying to get computers into secondary schools throughout Malawi. When we started in Malawi, only 3% of computers in the northern region had secondary schools had computers. We've now got that in the northern region up to about 80%, but obviously we've still got the central and southern regions in Malawi to go. And of course, many of these schools still need more computers because they actually want to have a computer per student. It seems obvious to us that that's what you want, but in Malawi, often at the moment, even with a computer lab of 20 computers, the students are often sharing. So we're taking donations from all sorts of organisations, schools included have donated to us, and it's very easy to get in touch through our website if you do think that you might have some machines that you no longer need, and we could benefit students in Malawi with. So thanks very much, Simon. That's brilliant. Thanks.
Cheers, thanks, Nikki. And obviously buying the Turing Tumbles obviously donates to the charity as well. So yeah.
So a seriously virtuous circle. So improving our kids' education helps improve other people's education as well. It's
excellent.
A circular economy that James would go on about.
So a feel good resource for that. Yeah, so my name's Simon Howe. I'm the Northwest Outreach Manager for CAS. I'm also head of IT at a school up in Manchester. And obviously I've done quite a lot of work with Nikki and the Turing Trust over the past couple of years. And obviously these great things which are Tumbles. So I'm going to talk you through some of the practical applications within the classroom, how you might be able to use it. I mean, firstly, you know, they're about £100, aren't they? I think, Nikki, around that sort of £89.
Oh no, they're 69 at the moment. But if you are a school or an educator, go and talk to them about it, because I understand there are a whole load of deals around there. So if people are buying in bulk or buying for classrooms and things, then it's probably significantly less than that.
Yeah, so make sure you drop them an email and see if you get some educational discount. So obviously, you know, the ideal scenario, you know, would be 30 in a classroom. You know, I can imagine that would be a bit crazy. The way we have them, we have about 10 set up in the middle of the room. You know, our rooms are quite fortunate because we've got a sort of a breakout space in the middle. So I have 10 there, and what happens is the pupils go and do them virtually, try it out virtually to plan it, and then they come and test them on the physical board as well. So it's sort of a mix, a blended approach, so everyone's sort of engaged. So that's sort of approach we take. So firstly, as Nikki said, you've got the guide here, which is online, the PDF guide, and this sort of guide has all the challenges and they ramp up in difficulty. And these are this is the stripped down version. As Nikki was saying, if you can look, I've got the book here as well. So the Tumble book, which is really good. If you've got like an after school club, this is really works really well. You know, if you've got a few keen computer scientists, mathematicians, you know, if you get them in pairs and they work through this book. And as we said, the book's quite nice because it's sort of done as a comic book strip, you know, a bit like a manga. And then what happens is you can see the sort of challenges which are based here. So that's the sort of the book which works well. So what you have is the whole premise of it is this is the required output here. So it's red. So 1, 2, 3, 4, 5, 6, 7, 8 red balls which are at the bottom. So these are your inputs at the top. So you have red and blue. So 2 inputs, and then at the bottom, here is where they'll line up here at the bottom here, and I'll show how it works in a minute. And as Nikki said, depending on which side it falls, it triggers a lever which then releases either a red ball or a blue ball. So this is the sort of decision path as it would be. Now the great thing is about this, pre-doing any programming, we use this quite a bit because what it allows people to do is just problem solve and use that sort of decomposition, abstraction, and that sort of critical thinking, which is really key and core, which I find to developing really quality programmers. So the idea behind sort of the way we put it into the curriculum is that sort of a pre-task to getting onto coding, just to get us thinking about those sort of core principles of computer science. So the simulator first, I'll show you here. This is a simulator. Obviously, it's free to use online. You can use it in your classrooms. You have all of the gates on the side of the screen here, and you can, if you just double click it, it flips them like so. You can see this here, and then you can drag the gates into where you want them. You know, the little bits. So that one wouldn't work that way. The internet's being a bit slow. And what you need to do is look at the book. I think I've done challenge 4 here somewhere on the board. 2, 3, here we go. Challenge 4, yeah. So I've got challenge 4 here. So what it says, it's going to be this output. So this is what we need to create. What it does, it gives you the setup. So the pupils need to set up the board like this, and it says there's 6 more available. So they set the board up like this. As you can see here, I've set it up on mine here. And what needs to happen at this point is the pupils need to then add the gates in to solve the problem. Now, if I was just to run this now, what would happen? In fact, I'm actually on the real board, and then we'll come back to this one. Let me take my camera off here. I'll show you. All right, so you should be able to see my board here. Oh, now the window is it all rainy. Just have a nosy. There you go. So you can see here, this is the board. Now, this is a different challenge which is set up, but if I press it, now you can stop this, it doesn't keep going. What happens there is you can see the balls fall down and they're not controlled. So the idea behind it is it's got to be a controlled flow. Yeah, so what we shouldn't be having is the ball dropping directly down. So this is how the board's set up. So what we have to
Simon,
do is
I don't think we could see your board. At least I couldn't.
On the camera, is the camera not
on? I can
you
see your screen, but not your. Or maybe I'm not looking in the right place. Oops.
My camera at the top. Can anyone else see that? Suzanne, can you see my camera? No.
Yes, I can see your where your camera is. That's you're still sharing your screen, but we can see your camera with your Tumble.
There we go.
That might be better.
Yeah.
That might be better. That's probably better. So yeah, so as you can see, this is set up, and what we need to do is get a nice flow to show it how it's going to fall nicely down to get the desired output. So the desired output for this one is all red lined up here. So if I just put these, reset it. There we go. So then I need to get my bits, and as Nikki said before, if you can see, I've got my little box of bits just down here. They're all sort of set up and all nicely laid out. That's back on. So then now what I need to do is put my gates in to get them to go the correct way and to make them sure they fall down the correct way. So what I'm going to do is put some of these gates in so it works. So I'm going to put them in here. And again, the idea behind it is to test it. So if I was to, let's just do a wrong way there. So again, I can test it. You see it's a bit smoother now, and now it drops all the way down. So the great thing is this is quite visual for pupils to see and test. So you can see that's the wrong way, so I'm going to pop it the right way. So it's going to flow really nicely down. And then I'm going to pop another one in here. And now when I do it, you can see the flow change. Until you get to the desired output. So yeah, so this is obviously one of the simpler challenges. Now there's loads and loads of different challenges which you can get with this. And there's loads of ways to test it. And like I said, as Nikki said, it's really nice to hands-on. I mean, there was one of the ladies in our maths club, she took one home over Christmas, and her two sons who were, I think they were 21 and 26, basically played with it all Christmas to try and complete the book, because they're really addicted when they actually, when you get going, when you see pupils in them, it's like an instant capture, you know, and to really think about those sort of core sort of problem solving skills with that. But yeah, so that gives you sort of an idea with how that works.
Right, Simon, I would just put in there the other thing that I've noticed is that you're using a different simulator to the one that I'm using. And I think that just tells, no. I think it's just worth pointing out that this is one of those things that's continuing to evolve. And the one that I'm using, of course, I've gone for the easier sort of option. It is the one that they currently sort of suggest from the website, so that if people are going through the website to find it, that's the one they'll come up with. And that already has the challenges pre-programmed into it. It just saves you a bit of time and a bit of legwork if you're in the front of students, that's all. Yeah, I think it's a, again, it's one of those things where you, sorry?
Before I show the simulator again, do you want to just show them where that link is on the website? Is that all right? Just so people can get to it quickly and make the present. You should be good to go. Now go through this.
Right, so if we, there we go. So this one calls itself Tumble Together Hero UK Heroku app. Yeah, there we go. So with this one, again, it's slightly different. Now let's move that out of the way. So up on the right hand side there, you've got some basic instructions that come up, fairly sort of self-evident, and then you've got the menu, and then you go and pick the challenges. Was that the one that you did? Well, this is one I quite like because I understand it. It sort of works for me.
I think number 4.
So this,
yeah.
So this one, you can see down here what bits you're allowed to use, and then you can just literally put them in. Now, again, as Simon says, one of the things is actually testing whether that's going to work. You can see I haven't used 2 bits there. So what's going to happen? Yeah, it just drops. It doesn't actually get down to the bottom. So I've obviously not finished doing this. So let's put one up there, and let's put one up there. Maybe not that way around, or that way around. Okay.
Technology.
Yeah. Okay. It's one of those things that I managed to get to do absolutely fine earlier. Well, let's see if we can move that one across. There you go. That doesn't want to do it. Okay, so that's a real new challenge. That's more like real life, isn't it?
Yeah.
So that one's not going to work. Oh, but it has actually reset it, so that's fine. So now, as you can see, as it's coming down there, it actually, depending on where it ends up, is which one is actually being triggered next.
Yeah, and it's showing the sort of that flow, and like we talked about before, that decision, so that path which it moves through, you know, and when we're talking about decisions within a computer system and why it does what it does, you know, it's about the path it follows in terms of its, you know, transistors, you know, your ones and zeros, what's passed, or your microchips or anything like that. So it's a really good way of visualizing it as well within. And like Nikki said, as you get further into the challenges, the higher you go, the more complex they are, and the more complex the solutions are.
Yeah. So
you know, to the problems.
Right. So let's.
Do you want to just fire a difficult one up just so we can have a look? Because I've got some more on the last slide.
Yes. One of the other ones I was looking at earlier was the quantum number one. So this is where they've introduced effectively bits or transistors here. So they're teaching students about how you're actually going to try and store information. So this is basically, can you actually store a number? And so you start with this setup, and then you actually have to work out where you're going to put your various bits. So I will. And obviously, we're starting with 8 balls, so we're going to try and count 8. So you can then say to students, well, okay, so if this was a binary system, what would you expect to see? You know, if you say that pointing in this direction is 0, pointing in to the right is 1, then what are you going to expect to see when you get to 8? And then you can actually just test your system. And as you can see, we've done 1 ball, so that one's turned to the right. We've done 2, so the next one has turned to the right. I should have put one down here, shouldn't I? That would have. Oh, well, maybe I shouldn't.
It's all right. Let's get this testing again. This is what it's about in terms of looking at what's going on.
It's about kids actually being able to work out what's gone wrong. Why isn't it working? Well, that isn't working because I've got it the wrong way around. So let's try that again.
There we go.
And now it's going to count to 8 if I'm very lucky. But again, it's you can actually see it happening in front of you. You can see the bits changing direction. So you can actually see what's effectively going to be happening inside your computer. And I find visualizing it like that really helpful.
Yeah, and I think certainly from my experience with pupils, again, it's that just the ability to work through a problem and test and develop and debug. So all these sort of words, you know, certainly Key Stage 3, you can bring this in, and then some of the more difficult challenges, like Nikki was just talking about, Key Stage 4, I found to sort of visualize it works really well about getting hands on. And you know, the simulator I was using is a bit more freestyle. So if you're getting onto the really sort of complicated stuff and you want to create some challenges yourselves for pupils, you know, it's a really great way to do that. I mean, Nikki, do you want to put the last slide on there for the challenges if you've got the slide short?
Yep, let me just pull that up. Right, so here we go. These are your top 10, I think. Well, it's your top challenges. These are the top
challenges. So I've sort of tried to break it down for you a little bit. So the sort of Key Stage 3 wise there, you can see it's the first sort of 15 challenges in the book, I think, work really well for Key Stage 3. And Key Stage 4 is, you know, you're beyond that, so 14 to the sort of end, which work really well and get them thinking about some core concepts. And like Nick said, if you have a read of them, it sort of does that linking for you. And then on the last one is the Key Stage 5. If anyone's Key Stage 5, the community has some really great resources. Yeah, excellent. The community has some really great resources where lots of people post particular ideas. This one I found really interesting, this pseudo random number generator. And again, this is, you know, quite a high level skill to sort of solve and challenge pupils, and certainly sort of Key Stage 5 it works really well with, and equally coming up with your own concepts for challenging pupils. But I think, you know, they're a great tool in the classroom. I think if you can get some physical ones in, works really well. Clubs, I would suggest maybe start, you know, that's what I generally test everything in a club, some keen beans, get them on it, get them trying it. It gives you a chance to figure it out and sort of iron any kinks out, and then start to roll it curriculum. I think it's a really good model to support you with that. I mean, we've got 5 minutes left, sort of intentionally done there before we get on to the prize draw for this particular tumble, which I've got in the kitchen. You know, that's what we'll be sending out. So have we got any questions you want to ask myself or Nikki before we do the draw? You just pop it in the chat. You should be able to see the question window, I think.
There's none as yet. Just to say, I've added the link for the Tumble Together resources website on the chat window, so you can access that.
Okay, and I guess the other thing I should do is also acknowledge the amazing support we've had from BCS over the years as well, with their regular donations over time. So that's something I can't remember when it was. I came back in maybe 2015 and met people in London, and you know, we've been getting donations from BCS and support ever since, which is again, I think it says something if you can get the community of sort of computer scientists and technology companies and all the rest of it involved, then I think it makes a huge difference. Certainly we appreciate it.
I don't think there's any
Absolutely.
questions. I can't see any. Can you see any questions?
No, just Emily's just said thank you. So I will pass that on. So yes, thank you to you both, really. So I suppose we could get on really with the prize draw, couldn't we? You know, thank you to you both for that, for introducing us to that. I myself, as was saying earlier, was lent a Turing Tumble last week, and that evening, I say, lost 2 hours of my evening, but I didn't lose them. Lost them productively, because it's just fascinating. Once you get into it, you just couldn't stop. So really good stuff. Okay, so we're excited to say that we've got a prize draw to win a Turing Tumble, as we've said. I've added your names, those of you that have attended, to a random name generator, so I'm going to run that now. Let's see, drum roll.
The suspense is killing me, Suzanne. Come on.
It's taking its time. Okay. So the winner is Emily S. So well done, Emily. We will contact you in due course to arrange the address to send it to. So yeah, well done. It's brilliant. Please can I encourage you to share your personal highlights from today's session via social media in the usual way, using that the CAS Inspire hashtag. At the end of this webinar, a short survey will appear on screen, and we'd be grateful if you could take a minute to complete that. So thank you both again for sharing your expertise with the Turing Tumbles today. It's been brilliant, and we hope to see you soon. Please come back after half term. We'll have a slightly different look to CAS Inspire. We're handing it over to you, our community. So please be in touch with your community leader if you'd like to be presenter of your own CAS Inspire session. So we look forward to hearing from you. Take care, have a good evening. Bye for now.
Thanks very much, Suzanne.
Thanks.
Bye, and congratulations again, Simon.
Yes, thank you.